Recent data from the James Webb Space Telescope suggests that the often overlooked Mercury may have much more fascinating history than previously thought, including the possibilities of previous life forms. This unassuming planet may hold secrets that will change our understanding of its nature and history. Mercury is considered almost unstudyable and extremely dangerous due to its proximity to the Sun, but recent observations by the James Webb Space Telescope have shown that Mercury may have a more complicated story to tell. Mercury, a rocky planet slightly larger than Pluto and significantly smaller than Earth or Mars, has traditionally been considered too hot to support life or vegetation. However, the discovery of bodies of water changed our perception of this world. Scientists have discovered that Mercury's temperature varies dramatically, with temperatures reaching up to 427 degrees Celsius during the day and dropping to around -173 degrees Celsius at night due to the planet's almost non-existent atmosphere. This discovery shows that certain regions, such as permanently shadowed craters at the poles, can maintain temperatures cold enough to hold water ice, challenging the previous belief that Mercury was too hot to hold water. Mercury's geological features are equally fascinating. The Caloris Basin, more than 1,500 kilometers in diameter, and the boulders, long and tall structures, suggest a turbulent geological history. In addition, the planet has small bright pits or cavities, probably formed by the sublimation of elements such as sulfur and potassium. These properties indicate that the surface and internal processes of Mercury may be more complex than previously understood. Historically, Mercury has been difficult to study because of its proximity to the Sun. The Greek astronomer Tis first recorded the position of Mercury in 265 BC, and several civilizations have made observations over the centuries. However, detailed studies became possible with modern telescopes only in the 17th century. In 1631, the French astronomer Pierre Gassendi described the passage of Mercury across the Sun, and in 1771, the German astronomer Jan Hermann Schur made important, though sometimes erroneous, observations about the rotation of Mercury. The orbit of the planet also confused scientists. In 1859, the French astronomer Urbain Le Verrier observed anomalies in the orbit of Mercury, which led him to propose the existence of a hypothetical planet called Vulcan. This theory was finally disproved by the theory of general relativity of Albert Einstein, 1915, that explained the deviations by the bending of space-time by the gravity of the Sun. Exploration of Mercury continued in 1974 with the Mariner 10 mission, which provided the first close-up views of the planet's surface and revealed surprising details such as a weak magnetic field and a thin outer sphere. NASA's Messenger mission, launched in 2008, expanded our understanding of Mercury by revealing vast lava fields, evidence of water ice and polar craters, and insights into the planet's geological history. Some scientists speculate that Mercury was once in the habitable zone of the solar system and may have harbored life before Jupiter's gravity pushed it in. This hypothesis is supported by geological features similar to Earth or Mars. The James Webb Space Telescope aims to shed light on these questions by using advanced imaging techniques to study Mercury's surface and atmosphere in unprecedented detail. These observations could reveal whether Mercury really is a lifeless, inhospitable world, or whether it has previously neglected structures and functions. Mercury's extreme temperatures and thin atmosphere and recent discoveries of water ice make it a subject of constant scientific intrigue. The planet's fast rotation speed and slow rotation create unique day-night cycles and solar radiation patterns. Despite the challenges posed by its proximity to the Sun, advances in space observation technology, such as the James Webb Space Telescope, promise to reveal more of Mercury's secrets, potentially changing our understanding of its formation, evolution, and habitability. In conclusion, Mercury remains a fascinating mystery in our solar system. Its harsh environment and small size contrast with its geological diversity, orbital dynamics, and water ice storage potential. Future missions and technological advances will continue to unravel the mysteries of Mercury and offer new perspectives on the evolution of terrestrial planets and the conditions necessary for life. The search for Mercury has always been a challenge due to its proximity to the Sun, resulting in extreme temperatures and high levels of solar radiation. The lack of a significant atmosphere means that there is no significant protection from the harsh rays of the Sun, making any flight to Mercury a formidable task. However, the scientific benefits of studying Mercury are enormous. as it offers a unique opportunity to understand the formation and evolution of rocky planets. Mercury's proximity to the Sun means that it was exposed to strong solar radiation and the solar wind, which probably had a major impact on its surface and atmosphere. The surface of the planet is covered with a layer of regolith, a mixture of dust and rock debris formed by billions of years of collisions between meteoroids and comets. These collisions created many craters, some of which are the largest in the solar system. The discovery of water ice in the permanently shadowed craters of Mercury was a big surprise for scientists. Those craters at the poles of the planet remain in permanent darkness and are cold enough to trap and store water ice. This discovery suggests that the history of Mercury may be more complex than previously thought, and that there may be volatiles on the surface of the planet. One of the most fascinating aspects of Mercury is its magnetic field. Unlike most other rocky planets, Mercury has a magnetic field, although it is much weaker than Earth's. The presence of a magnetic field indicates that Mercury has a partially molten core that generates a field through a dynamo process. Understanding Mercury's magnetic field can provide valuable information about the planet's internal structure and thermal history. The Mariner 10 mission, launched in 1973, was the first mission to provide detailed images of the surface of Mercury. The spacecraft made 3 flybys of the planet and photographed about 45% of Mercury's surface. These images revealed a heavily cratered surface similar to the Moon, with large impact basins and flat plains. The Mariner 10 mission also detected Mercury's magnetic field, providing the first evidence of its existence. After the Mariner 10 mission, there was a long pause in the search for Mercury, and no flight was made to the planet for more than 3 decades. That hiatus was partly due to the challenges of sending a spacecraft to Mercury, as well as the high cost and technical difficulties of such missions. However, in 2004, NASA launched the Messenger mission, which provided a wealth of new information about Mercury. The Messenger spacecraft entered Mercury's orbit in 2011 and conducted an extensive survey of the planet's surface, atmosphere, and magnetic field. The mission provided detailed images of the entire planet, revealing a diverse and dynamic surface with evidence of volcanic activity, tectonic movements, and long-term geological processes. Messenger also confirmed the presence of water ice in Mercury's polar craters and detected many other volatiles, including sulfur, potassium, and sodium. One of the most important discoveries of the Messenger mission was evidence of past volcanic activity on Mercury. The spacecraft identified large areas of smooth plains likely formed by ancient lava flows, as well as volcanic vents and pyroclastic deposits. This evidence indicates that Mercury was geologically active in its early history and that its surface was shaped by significant volcanic activity. The discovery of cavities on the surface of Mercury was another important discovery of the Messenger mission. These small, shallow depressions are thought to have formed as a result of the sublimation of volatile materials such as sulfur and potassium from the surface of the planet. These cavities are unique to Mercury and provide insight into the planet's geochemical processes and the role of volatiles in shaping its
surface. The Messenger mission also studied Mercury's exosphere, or the thin layer of gas surrounding the planet. The exosphere is composed mainly of helium, hydrogen, and minor amounts of other elements such as oxygen, sodium, and potassium. The presence of these elements in the outer sphere provides clues about the processes that release gases from the surface of Mercury and the interactions between the planet and the solar wind. The James Webb Space Telescope, JWST, promises to transform our understanding of Mercury by providing unprecedented detail about the planet's surface and atmosphere. JWST's advanced imaging capabilities allow scientists to study Mercury's composition, geology, and potential to store water or other volatiles. By observing Mercury's transit of the Sun, JWST will analyze the characteristics of the planet's atmosphere and surface, providing new insights into its geological history and possible habitability. The possibility of water ice on Mercury is particularly important because it raises questions about resource availability for future expeditions. Water is a critical resource for human exploration, and the presence of water ice on Mercury could be a valuable source of water for astronauts and potentially support long-duration missions to the planet. Studying the geological history of Mercury is also important to understand the evolution of the rocky planets of the solar system. Features on Mercury's surface, such as impact craters, volcanic plains, and tectonic structures, provide information about the planet's geological processes and can help scientists piece together its history. By comparing the geological features of Mercury with those of other rocky planets such as Earth, Mars, and Venus, scientists can gain insight into the processes that formed these planets and the conditions of their formation and development. Mercury's unique location in the solar system close to the Sun also makes it an important target for studying the effects of solar radiation and the solar wind on the planet's environment. The planet's proximity to the Sun means that it experiences extreme fluctuations in temperature and sunlight, which can have significant effects on its surface and atmosphere. Understanding these effects can provide valuable information about the interactions between the Sun and its nearest planetary neighbor and help scientists